Alright, hey guys, and welcome to this video discussing this idea of slope. And what is slope, and how does it relate to these real-world situations we're describing, and also the table of values, and the equations, and the graphs that we are using to describe them. Okay, so in this example, I've chosen something that's pretty simple, hopefully so that it offers us an easier way to introduce this idea of slope. And so in this example, you decide that you'd like to save up for an iPhone. And you start saving on February 26th. And on that day, on February 26th, you had $6 in the piggy bank, and you save an additional $2 every day after that. So you put $2 more in the piggy bank every day thereafter. And I've already gone ahead and defined the variables. I hope this wouldn't be an issue for you, that the independent variable will be the number of days after February 26th, and we'll call that X. And our dependent variable will be how many dollars you have in the piggy bank, and we'll call that Y. And before we do anything else, I really like to make a table of values to kind of organize that data. It's nice to have it all right in front of us in case we want to try and get any conclusions from that, or perhaps use it to help us make our equation. I'm going to label the columns just X and Y. Of course, X is the number of days since February 26th, and Y is how much you have in the piggy bank. So on February 26th, 0 days after February 26th, you had exactly $6 in your piggy bank. And every single day that goes by, you put $2 more in your piggy bank. So 6, 8, 10, 12, 14, and 16. And of course, we could go on forever and ever. So now we have a table of values to describe this situation. And also, I hope that we feel comfortable creating an equation to describe this relationship as well. And I think that equation would be why the number of dollars we have in the piggy bank, it kind of started at $6 and it went up by $2 every day that went by. So Y equals 6 plus 2 times X. Okay, what I'd also like to do is to sketch a quick graph to represent this situation. So I've got our vertical axis here. Try my best to make it straight, that'll have to do. And we've got a horizontal axis here. And we're not going to be able to fit too much of this on our graph just because the Y values go up pretty quickly, but alas, it'll still help when we discuss this idea of slope. So and we're going to have on this graph both the number of days and the piggy bank are going to start at 0. And for simplicity and to help kind of highlight what this slope idea is and how it shows up on a graph, we are going to make one box on the horizontal axis represent 1 day, and one box on the vertical axis represent $1. So it's just kind of like a 1-to-1 ratio. Okay, so on February 26th, we had $6 in the account. So 1, 2, 3, 4, 5, 6. And of course, by $6 in the account, I made $6 in the piggy bank. 1, 2, 3, 4, 5, 6. Okay, after 1 day, the amount of the piggy bank went up by $2. So 1 day later, went up by $2 for a grand total of 8. 1 day later, it went up by $2 for a grand total of 10. 1 day later, it went up by $2 for a grand total of 12. And of course, this would continue on and on and on. And while I think a discrete graph is definitely the most appropriate for this situation, I'm going to connect these dots just because we're going to often be working with continuous graphs later, and I want us to be able to understand this when we're dealing with continuous graphs. So we're looking at that graph right there. Okay, so I hope we can see where this 6 in our equation shows up in both the table of values and on our graph, and how it pertains to the modeling situation we have, right? On February 26th, there was $6 in the account. That coincides with that ordered pair in our table, and this parameter in our equation, and this point on our graph. But I really want to focus in on this 2 in our equation. This 2 has everything to do with the fact that you save $2 additional every day. You put $2 more into that piggy bank every single day, right? And you can see this, of course, on your table, that every time the number of days goes up by 1, 1 day goes by, 1 day goes by, 1 day goes by, the number of dollars in the piggy bank goes up by 2, goes up by 2, goes up by 2, goes up by 2. And my question is, how would this show up on our graph? Well, I think if you look at this graph, and I kind of counted it out for you as we were drawing it to kind of make it clear, we obviously started with $6 in the account, and when 1 day went by, we put $2 additional in. When another day went by, we put $2 additional in. When a day went by, we put $2 additional in. And so I think that this 2, the kind of rate at which you are saving, the rate at which our piggy bank amount goes up, that kind of determines the steepness of this line, or dare I say, the slope of this line. Interesting, interesting, interesting. And I want to give you a kind of, first a really formal definition of slope, and then one that we're going to use a little bit more as well. And so we're going to be doing a lot of modeling of real world situations using lines. And I claim that lines can go up, they can slope upward, they can go down, they can slope downward, they can be really steep, they can be not so steep. And so we really want to kind of focus in on that part of the lines and what that has to do with everything. And so the first thing I'll say is that we can think of slope as a rate of change of y, or whatever our dependent variable is, with respect to x. So that's a really kind of formal and lofty way of talking about slope. It's saying, well, how quickly is y changing? Is it increasing? Is it decreasing? Is it increasing quickly or slowly? Another way to think about slope is this. The slope, we can think of it as this. We're saying, what was the change in our y values? And actually I'm going to write this out. The change in y. Right? Did y change a lot? Did it go up? Was it a positive change? Did it go up? Was it a negative change? Did it go down? In this case, it was a positive change. And was it a big change or a small change? But of course, that's not enough, right? If I told you that you saved $30, well, is that a lot or little? It depends on how many days that took. Did that take one day and you saved $30 in one day? Or did it take, 50 days and you saved $30? In which case, you're not really saving very much at all. So the slope is going to be the change in our y values, and we're going to divide that by the change in our x values. And another way to think about slope, or another way to write slope, and this is super duper important, so I'm going to write this in slightly bigger ink, is the slope we can think of as, well, the change in y, we can write that in another way. We write this Greek capital delta y, and delta y means change in y. How much has y changed? Over delta x. And this means change in x. So oftentimes when you see that kind of a triangle, it's going to be meaning change in, change in. And so we can see, for instance, that, and I'm going to even take this 2 down here, and I'm going to rewrite this 2 as though it were a fraction. I'm going to write that as 2 over 1. You can think about it as 2, but it's the same thing as 2 over 1. So right now, our slope is 2 over 1. And what does that mean with regard to our table and our graph and everything else? It means that for every 1 day that goes by, we put $2 more in the bank account. In the piggy bank, with $2 more in the bank account. Now this is a ratio, or this is a fraction, and there are many equivalent fractions to 2 over 1. We can write it as 4 over 2. Right? And 4 over 2 means for every 2 days that go by, you put $4 more. So from 0 to 2, we went from $6 to $10, $4 more. Or from 3 days to 5 days later, $12 to $16. You went up $4. How does that show up in our graph? Well, if we were to go 2 days, so that's 2 days right there, 2 days to the right, we would put in $4 more. Oh, or I'll do this one in hot pink, right? So what about 6 over 3, another equivalent ratio? This is still the slope, it's still the change in y over the change in x. And for every 3 days that goes by, right? So from 0 to 1, 2, 3 days, the amount in the piggy bank went up from 6 to 12, $6 more. And on the graph, if 3 days go by, we put $6 more in the piggy bank. So it's really important that we understand this idea of slope representing a rate of change. How many more dollars are we putting in every day? The change in y over the change in x, how it shows up on our table of values, how it shows up on our graph as well. And I want to